Okay, now we're going to take a look at how side, angle, side triangle congruence work. So just to recap, if two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the triangles are congruent. Keywords here that I want you to underline or highlight is two sides and the included angle. Again, two sides and the included angle. Very important that you recognize that it must be the included angle. Okay, so let's get started. First thing I do, always look at my given information and make note of where I'm going. So what I want to prove is that triangle ABD is congruent. ABD, this triangle, is congruent to triangle CBD. CBD, to this one. Okay, so I've got a great big triangle and then the two smaller triangles, and I want to prove that those two smaller triangles are congruent to each other, and I'm going to do that by finding two sides and the included angle from one triangle that are congruent to two sides and the included angle of the other triangle. If I can find those two sides and that angle, those three parts, if I can find those on the two corresponding parts to be congruent, I will have congruent triangles. All the other parts will be congruent also. Okay, so first thing, side, two letters with a line over it. That means the side. Side AB is congruent to side CB. So let's mark that. AB congruent to CB. Now we're looking at side BD bisects angle ABC. So here's BD. That. This is a bisector, so it divides this angle into two congruent parts, which means then that this angle is congruent to that one. Okay, so far I've got one side here congruent to a side there, one angle here congruent to an angle there. Now, my only option is for a side angle side, two sides, the included angle. Okay, so I got the two sides. Here's the angle. So this is the side that is my only option, because there's the side, angle, side. Side, angle, side. So this has to be the side. Well, as it turns out, this side BD is a side on both of those triangles, so it's obviously congruent to itself, which means it's going to be the second congruent side that I need. So I can start my proof because I can mark that part of it. So now I have my side, angle, side. So AB is congruent to CB. That was given information because it was right there. BD bisects angle ABC. Again, it's right there. That means it is given information. Now, this is the information that I am pulling because of this bisector. Angle ABD, this angle, my little green angle there, is congruent to angle CBD, this angle. So those two angles are congruent to each other because that is the definition of a bisector. So a bisector divides the angle into two congruent angles, so definition of bisector. And then BD is congruent to BD. It's the same line. So that is called the reflexive property. And now I have proven by side, angle, side that those two triangles are congruent. So the last thing that's always written here is whatever it was that I had to prove. That goes there, and then how did I do it? I did it by finding a side, then an angle, and then a side. Side, angle, side. Okay, let's take a look at the next one. Okay, so we've got given information. V is the midpoint of WZ and XY. So V is the midpoint of WZ and XY. Okay, that doesn't necessarily mean that all four of these sides are congruent to each other. This is the midpoint and divided this line into two congruent parts. So that is congruent to that. And this is congruent to that. That is all that we can state for sure. Now remember, once again, this is going to be an angle side angle, and the included angle must be between the two sides. So my only option for an angle is these two. This angle must be congruent to that. As it happens, what kind of angles are they? Right, vertical angles, and vertical angles are always congruent. So I'm going to mark my vertical angles. It's congruent. Now I have side, angle, side, to side, angle, side. Congruence. So now I start with my proof. First thing, V is the midpoint of WZ and XY. That was given. And then WV is congruent to ZV. WV is congruent to ZV. That was definition of midpoint. So keep something in mind. When we're being told about bisectors or midpoints or parallel lines, which you'll see in the next one, that in itself is not telling us two angles are congruent or two sides are congruent. And notice over here, that's all we have. When we're setting up our proof, we want to make sure that we've set up congruent sides or congruent angles, depending on what kind of a statement we're making. So certain parts of information lead to the congruent sides or angles. Bisectors and midpoints are what lead to congruent sides or angles. So we write those down, but then from those we get our congruent sides in this case. Okay, and then we have angle. WVX is congruent to angle ZVY, and that's by vertical angles. So we have our vertical angles are congruent. Then we use the other side. So this is set up nicely to show that we have a side, and then an angle, and then here's the second side. And that again was definition of midpoint. XV is congruent to YV, so that was these ones. And that's our last part that we needed. So now we have the side angle side, and then we just put that there. We've shown that. Remember, the last space is always devoted for what we had to prove. Now notice we never would put over here. Even though we're taking this and putting it here and putting the word given, we don't use the word prove over here. We put over here what we did. We proved it by side, angle, side, how we proved it. Okay, let's look at this last one, and this is an important one too because it is also presenting new information to you. So what I'm looking at is our given information. I'm trying to prove this triangle is congruent to this one. So I start out with HI is congruent to JG. HI, JG. Now my next bit of information is that those same two lines are parallel to each other. So I put the arrows that show parallel lines. Okay, so now I have to realize that, remember, when I have two parallel lines and a transversal going through them, I end up with congruent angles. These two angles will be congruent because the alternate interior angles that are formed by parallel lines are congruent. And this is going to be a side angle. Third side has to be, or the second side has to be, HJ by a reflexive property. So now I have my triangle all set up. I'm showing how I've got it congruent. So now I'm just going to follow through with filling in my proof. My reason, always. The first thing, I don't even have to look. The first thing that goes here is my given information, and I write given here. Then this is my next bit of information. That one you do have to look, because sometimes it's not in the same order. And that will depend on how you are setting this up. Okay, and then the information I got from the parallel lines leads me to be able to state that angle GJH, J, the middle letter is where my vertex is congruent to angle IHJ. There. And that is because the alternate interior angles that are formed by parallel lines are congruent. I don't have to put the whole parallel line business in there. I can just say alternate interior angles are congruent. And then HJ is congruent to JH by the reflexive property. And I have proven my triangles congruent by side, angle, side. Ta-da, done. Okay? Good luck.